I'm J.R. Rivers. I'm with Amazon or AWS, senior principal engineer in the network services organization. We're responsible for a lot of stuff, but among other things, all of the infrastructure networks that run the big data centers, the global backbone, and our border networks. I've been, as you can tell, I've been in the industry for quite some time, and I grew up in this era where network systems were like big, expensive pieces of equipment that had names, and people knew what those names were, and they logged onto specific devices on purpose. And you could, back in those days, you could talk to a customer and they would tell you like all of the idiosyncrasies of every ASIC that the vendor supplied, and maybe given a particular software release, which bugs were in it and which bugs were going to be fixed in the other releases, and when they were going to roll them out and when they were expected. And there were they would wait patiently for these releases to come out of their favorite OEM supplier. It was kind of almost like a car enthusiast would know the ins and outs of like a Ford Shelby or something like that. The software releases were reasonably rare, and when they came out, they were often highly anticipated by one set of the customers, and then also highly feared by another set of customers. And sometimes that was actually just two personalities inside the same customer, or even the same admin, because you were waiting for a feature, or a function, or a bug fix or something like that, but you were always afraid that something might break along the way, and you'd be caught unawares and be up till the middle of the night trying to get things fixed. And in that world, it wasn't very uncommon, and actually in many of places in we'll call it enterprise, or even some data center type networks or cloud type networks, to see switches and routers that have been operational for years. If it's up, if it's performing a function, I don't really need to touch it. I don't use it. And so you often would see these situations where you could log on to a box and it was up for 5-6 years. Now, if you try to unwind that and unpack it in the context of what's going on inside of a cloud provider like AWS, we have very, very high standards for security and reliability, and our performance characteristics are just insane, and the system just grows and grows and grows at in a somewhat chaotic manner. And I say somewhat chaotic. There are planning tools that tell us what capacity needs to land where, but it goes all over the world, and there's various teams working on this at various points in time, and they're all in order to make progress at the rate we need to make progress at. They can't all be tightly coupled or coordinated. They need to be able to loosely couple and work. And this is a world that we exist in where a switch can't remain untouched for years. A router has to be updated in a reasonable time frame. Like we have to scale our network. We have to update our configurations to allow new ports to be enabled. We have new features or telemetry that shows up. We have alarms that we want to add to the system, or we have mitigations we need to run on the system. Given our security consciousness, we have credentials that need to be rotated. We close our security vulnerabilities. This is really, really complex technology when you think about a network that is expected to be up all the time. And I know NDCSI spends a lot of time on like underlying protocol characteristics or behaviors of data path, or maybe routing control planes and all that. But those are, we'll call them important pieces of the puzzle, but operating a network is as or more important to most institutions than what the network does. It sounds somewhat blasphemous to say that, but running a network at scale is complex. And when you look at most of the customers of networks, where do they spend their money is mostly around managing operational teams and ensuring that the applications that generate revenue or kind of business critical are able to communicate in a way that makes sense and provides the business value that's expected. And so what we've done at AWS is kind of built this system that makes deploying to our network look structurally a lot like it would if you were deploying containers or microservices into the cloud itself. So if you unwind a classical continuous integration or continuous delivery pipeline, it's pretty simple. You have, your source code, you build that, you run it through some sort of test, and you stick it into production. And for those of you not familiar with all the different variations, the CI part is the continuous integration. That means if I make a code change, I check it in, it'll get slurped up at some point in time automatically and get built, and the result of that build will be available to be processed. I don't have to actually make it myself; it'll automatically get built. The CD part that you see when you hear CI/CD can either mean delivery or deployment, and people kind of break it in various spots and argue it. But the delivery part would be when you take that automatically built code and you run it through a set of test sequences and you put it into a spot and say, hey, I'm ready to push this out into production as soon as somebody gives me the go-ahead. And a continuous deployment pipeline would take that thing and then automatically push it out after it's passed the test. Some people in super mature systems will go all the way to that continuous deployment type environment where you check in a change, it goes through tests, starts rolling itself out. If it, as it's doing rollouts, if things change, you'll roll back and then, go all the way out to full production, untouched by human hands along the way. We're not quite that sophisticated, at least on the networking side. We have like a whole set of kind of checks and balances where we stop along the way. But in general, the pipeline looks like kind of a more extended variation of that classic CI/CD pipeline. So we have the source, build, and test part like you would expect. But then we go back through and go through an integration phase where we take all the various components, both like a switch and router components, and then all the tools that get coupled with those things and operational behaviors, and run those things, integrate all that together and run it through an integration test. And then after the integration test pass, we run through what we call a canary process, where we take various devices in the fleet and cycle them through and run their upgrades, whether it's a configuration upgrade or an actual OS upgrade. We'll upgrade these canary devices and we monitor those things for a while to make sure that they make sense and their behavior hasn't changed, or if it has changed, it's what we expect. And then eventually, once the canary phase gets solid, then we go through and roll this thing out into full production and upgrade the entire fleet. I know there's a couple people from AWS on the line right now, and some of them are super old timers. They remember when this stuff was really painful, but we've gotten to the system to the point where it's pretty fast right now, where when we've got an OS upgrade, we can roll it through the fleet. I don't think I'm at liberty to tell you what the time frame is, but it's pretty astronomical how fast we're able to upgrade the fleet. And as the presentation started off with, we do this while the plane's flying. One of the characteristics of AWS is that we actually deliver obviously a ton of services to our customers, but we also deliver instances. And many of our services run on top of those instances. So if you unwind the innate characteristics of the AWS system, it delivers compute instances and storage to customers. And so in the context of delivering an instance, you can't just drain a data center today and say, hey, you know what, I want to upgrade that data center. I want to upgrade this rack, or I want to upgrade this row. I'm going to drain the services off the row, and I'm going to upgrade that row with the new OS version. I'm going to put services back on it. That's what you would do if you were a customer and you were deploying a container-based application. You would go through and say, hey, you know what, if I need to upgrade either my containers, or if I need to upgrade the underlying OS underneath the container visor underneath my containers, I would take all of my container services off of that host. I would upgrade the host, and then I would put things back on it again. We can't take the load off of our servers, but what we can do is take load off the network. So what we do is we go through this process at the most rudimentary and simple level of go through, figure out what needs to be updated. Some of the devices in the network are such that we can shift network traffic off of them, and we evaluate for redundancy and capacity and all these other pieces, which we'll talk about a little bit more later. We rotate off of those things, we upgrade those devices and shift the traffic back. And then other places in the network where we have devices that are more critical, we actually do hitless upgrades on. So we'll go through and do set them up, prepare them, add new configuration, modify existing configuration, and then do a warm upgrade into a new OS image. All of that stuff is going on at the same time, the canary type in the production process, as maintenance events that are happening worldwide in all of our data centers everywhere, all by themselves. We have, large scale and small scale events. You'll be in some region and somebody will take a backhoe to one of our fiber infrastructure, or there'll be a building fire somewhere that burns something, or all these crazy stuff happens in the world. We're constantly scaling the system. So we're adding new data centers or new capacity between data centers all the time. And then we obviously have scheduled operations where we're doing large scale shifts of things, as we're maybe, like I said, adding a new building or doing a big server upgrade somewhere. And so there's a tremendous amount of things that want to do things to our network that go on at the same point in time. And this system is what, kind of want to spend some time talking about that today. This thing has to consider capacity requirements, has to consider redundancy. It has to understand clashing, like what can be upgraded at the same time as something else or not. We pride ourselves and beat ourselves over AZ independence. So how do we make sure that if something goes horribly wrong in one AZ, it doesn't impact any of the other availability zones inside the region? And then obviously, certain operations have, greater or less priority than other operations. So we have a system that goes through and manages all of those pieces. It takes, at the left side, kind of the input of all the work that wants to be done during that time frame, and then we have this thing, we call them campaigns, that get created, and each of these work items get submitted into this scheduler through a series of campaigns. They go through and they select the devices, either individually or through groups, or kind of, we'll call it metadata assignment of campaigns to specific sets of devices, identifies what operation we want to apply to the device, and all that stuff gets tagged in these campaigns. All of that data goes into this great big ginormous scheduler that tries to figure out, first off, how to get anything done, period, because there's a tremendous amount of information. But more importantly, the team that works on this try to figure out how to get things done optimally. How do we take all of this work and be the absolutely most efficient with use of time? How do we make sure that we find the right cracks and bin pack the work so that one particular operation doesn't squeeze out other operations and block them? How do we schedule them for when do we have the most amount of network usage or the least amount of network usage? Which ones have the opportunity of getting through the system very, very quickly if we schedule them up in an interesting way? And then also, what activities have we put into the queue that haven't been done, like they didn't get done yesterday, or they were evaluated and we had to skip them for a while, but let's go back and get to them more quickly. So we kind of recirculate inside that queue, inside that scheduler, to make sure that when work needs to be done on a particular device, it gets done as quickly as possible, and it doesn't always fall to the back of the line. That system figures out what work gets done next, sticks into a set of work queues. Those work queues then start delivering, dispatching into the environment. And as we go through that dispatching operation, if a piece of work can't be done for whatever reason, that queue drains it out, circles back, notifies the scheduler. The schedule restructures itself based on work that it now knows can't be done, creates a new set of queues, again, leading up to that dispatch operation. And then, forward from there, we go out of the dispatcher into device type operations. These types of systems are incredibly complex, and to some degree, the network and graph effects of them are kind of more complex and more chaotic, and even more more interestingly, computationally, than understanding things like routing protocols or anything else like that. Because when you go back and look at the effect of any one device, and then how it affects the other devices, and how you can break those chains and create the right set of work, monitor that the work is flowing through accordingly, and that you didn't break something along the way, and then and the network continues to be safe, is just incredibly complex. And this system in the context of AWS is dealing with like hundreds of thousands of operations every single day. And we're continuing to scale it. Like within my time, I've been at Amazon for a little over a year now, and the scale of this system is doubled in the time that I've been here. And so it just continues to grow and grow and grow and become more and more sophisticated. So that's what I was hoping to talk with you all about. We're in a situation now where in AWS, when if this human was allowed to log onto a switch, you're looking at uptimes in the order of days instead of the orders of years. And that's exactly where we need to be to make sure that A, we have the most secure network, and B, we have the most performant network that we can. So thank you. And I wanted to open this up for questions at this point in time.